we'll be looking at the surface area of other composite objects. So we will still be using the top, bottom, front, back method. So let's look at a couple of examples. So the first example here is we have a trapezoid for the front and the back. So the front and back will still be the same. So let's do that right now. So let's start with front back. So the front back, if I were to look at it directly in front, I would see, like I stated before, a trapezoid figure, which is basically a triangle over a rectangle. So if I calculate the surface area of the triangle and the surface area of the rectangle and add both together, I will get the surface area of the whole front. And then I'll just double. So let's do that. So the rectangle, let's start with the rectangle, has a base of 8 and a height of 4, so that the rectangle will have a surface area of 32 centimeters square. Now the triangle has a height of, well, if the whole height is 10 and that's 4, this has to be 6. So 6 times 8 is 48. However, a triangle is only half of a rectangle, so you have to do the area divided by 2. So 48 divided by 2 is 24 centimeters square. So remember, area of a triangle is base times height divided by 2. So the total surface area of the front would be 56 centimeters square. And that means the front and the back would be a total of 112 centimeters square, just doubling that. All right, now let's take a look at the top. Now, if I were to look at the top, it would be a rectangle, but the top would be different from the bottom because it doesn't have the same dimensions. So the top is a longer rectangle because it has a dimension of 10 by 3, which would give it a surface area of 30 centimeters square, while the bottom is also a rectangle, but it only has dimensions of 8 by 3, which is 24 centimeters squared. So we couldn't do those together and then double it like in the previous section. The same could be said about the left side and the right side. We have to do them separately. So if I take a look at the left side, it is also a rectangle, but it has dimensions of 10 high and a base of 3, which would make it 30 centimeters squared. While the right side is a smaller rectangle right here. That's the right side, which is just, oh, that's not a rectangle. It's more like a circle. There you go. There's your rectangle, and it has dimensions of 3 by 4, which gives me an area of 12 centimeters square. So that means that the total surface area would be 112 plus 30 plus 24 plus 12 plus 30. So surface area is 112, which is the front and back, plus the top, which is 30, plus the left side, which is another 30, plus the right side, 12, and the bottom, 24. So if I add all that together, I have here's 60 for those two. Those two have 36. 36 plus 60, that's 96. 96 plus 112 is 208 centimeters squared. That is the total surface area of this figure. All right, so let's do another example with circles. So this one here, I have a cake, and I want to frost this cake. I have all the dimensions in the figure. The only thing here, a cake, you do not frost the bottom, so we will not be doing the bottom. We'll just be doing top, front, back, and left, right. However, let's start with the top. So if I were to look directly above, I would see this circle and then a ring. But the ring and the circle together do a full circle. So then I just need to find the area of that circle, which has a total radius of, well, remember that the formula for the area of a circle is pi multiplied by the radius squared. So the radius here is half the diameter, which would be 13. So all I need to do is square 13. So 13 squared multiplied by pi, which is 3.14. So square 13 is 169, and pi, which is 3.14. We're not going to do that because you don't have a calculator, so you just leave it as pi. And if you ever want to know what the area of that circle is, you just take a calculator and do 169 multiplied by pi. But because you're not allowed a calculator, you just leave it as 169 pi. All right, so we did the top. There's no bottom because we don't frost the bottom of a cake. So now we're going to look at the front, back, and left, right. Well, here we don't really have a front, back, left, right. It's just like a wrap, but we have two wraps. So that's what we're going to do. We're going to look at the wrap. We'll call it wrap 1, which would be the smaller one here, we'll say. And if I were to take that, it looks like a can. If I were a cylinder, if I take the label off a cylinder, I get what kind of shape? Well, if you think about it, if you peel off the label, you'll get a rectangle. And I know what the height of the rectangle is. It's 5. And the base is the circumference of the cylinder or the circle. So the circumference, there's a formula for that. It's just pi multiplied by the diameter. Well, the diameter here is 14. So that means it's 14 pi. And I don't multiply pi because I don't have a calculator, so I just leave it like that. And that means the area would be 5 times 14 pi, which would be 70 pi. So the first wrap is 70 pi. So the top is 169 pi, and the first wrap is 70 pi. So I'll do the same thing for this wrap here, call it wrap 2, wrap 2. And again, if I were to take the label off a can, what shape would I get? I would get a rectangle. This one would be a little bit longer. And remember that it's the height, which is 5, the same. And then it's the diameter multiplied by pi, which is 26 pi. So the area of that would be 5 times 26, which is 5 times 2, 20 is 100. 5 times 6 is 36. So 5 times 100 plus 36 is 136 multiplied by pi, and I just leave it like that. So then if I want my surface area, all I do is I add the top, which is 169, and both wraps. So the surface area is going to be 169 pi plus another 70 pi plus another 136 pi. That's going to give me, well, let's see, 136, that's 206, these two here, 206 pi. What did I say? Yeah, okay, so it's 22, so 206. So that's going to be 375. So 360 plus 15, so 375 pi and centimeter square. There you go. Let's do one final example and that'll be it. Oh, we can leave, well, yeah, so one final example here. This one here is a little bit tougher. So we'll just do this one here. We have a birdhouse, and what we need to do is we need to calculate the surface area of this triangle here. So let's just do that and then we'll be done. So I'm just gonna draw that triangle a little bit bigger here so you can see what exactly is happening. So I have a triangle, and I know that all sides are 2, but the problem is that the surface area of a triangle is the base times the height divided by 2. I don't have the height, but what I can do is I can do a right triangle. I know the base would be 1 here because this would be half and that would be half. And I could find the height of the triangle by doing Pythagorean theorem. Now this is the hypotenuse. So I know that this side here would be the difference squared between these two sides. So that's what I'm going to do here. So I'm going to do the height is going to be equal to the hypotenuse squared minus the base 1 squared. So the height squared would be 4 minus 1, which would be 3. So the height's not 3. The height is actually the square root of 3. So if you approximate that, you're looking to find the square root of 3. It's between the square root of 4 and the square root of 1. Well, that's 1. That's 2. It's a lot closer to 4 because there's a difference of 2 and 1, so it'd be like 1.7. That's a good approximation. So the height would actually be 1.7, 1 and 7/10. So now we have all we need to find the surface area of the triangle. So the surface area, remember the formula of a triangle. So the surface area of the triangle is base times height divided by 2. So that's the base, which is of the full triangle. So now we're back at the full triangle, which is 2. The base is 2, multiplied by the height, which we just found, 1 and 7/10, divided by 2. Well, if we have something that we multiply by 2 and then divide it by 2, these 2's are going to cancel out. So the surface area of this triangle right here would just be 1 and 7/10 meter squared. So that's how you calculate the surface area of a triangle. If you're missing the height, you create a right triangle and you find the height using Pythagorean theorem. Here's your practice. Make sure you check your work behind the book.